our next speaker will be Melissa Elkadi, I believe. She's here. Yes, she's there. From EpiSci, and she will talk about the 5G emulator.
Okay. Yeah, I'll do this one. Okay. Hi, I'm Melissa. I can't believe you guys convinced me to get back down here, but I'm here. So I am from EpiSci. Yesterday I was talking about 5G sidelink, and today I'll be talking about our 5G emulator, and we've coined the term 5Gem. So first, I'm going to go over a quick agenda. I only have 5 minutes, so I'll be real fast. It's really going to be the who, what, where, when, and why. And then you can come to the booth and hear the how. So for starts, let's start with who is EpiSci. EpiSci is a local San Diego business that is developing multi-agent technology for airborne, space, maritime, and land domains. Our core technology is tactical AI, and we recognize that 5G is an integral part for enabling multi-domain autonomous systems. Our workforce is diverse, highly skilled, and expert workforce. We have about 40 employees right now. We have a wide, diverse education background, and about half of our employees have clearances. We hope by the end of next year to have between 70 and 80 employees. So any of you 5G or AI machine learning engineers, come see our table or reach out to us on LinkedIn. So now for the 5G emulator, I'll skip over the UE, G-Node B, E-Node B base station stuff. I think we've talked about that enough today, but we will focus on our PHY emulator in the middle. So the PHY emulator is created to basically allow us to provide channel models in real time. And again, I'll skip over OAI, but we're using EpiSci in this demo to basically be that interface between the MAC and the PHY layers. So the objectives of this work are to illustrate the importance of a fully emulated PHY layer. The fully emulated PHY layer allows us to have better validation tests and performance evaluation for various protocols and wireless networks. In the demo, we hope to showcase the features that we've added to OAI and EpiSci for both LTE, NR, and NSA mode. We'll demonstrate the fully scalable models. We can get up to 25, 35 LTE UEs. I think we're at 15 NR UEs now, and maybe 12 NSA UEs. And this is all with an emulated PHY layer in an open source proxy. And then we'll showcase a few different channel models and applications of what we've done. So this here is the 5G OAI block diagram. I'm not going to go over this in too much detail. The next slide sort of, I don't have enough time. So it'll talk about really the important parts. So basically, our primary area of work was in the lower MAC and putting in the EpiSci interfaces to communicate with the PHY layer, which we've moved into our open source proxy. So we've moved the UE PHY layer and the G-Node B PHY layer along with the PNF into the open source proxy. And the PNF will communicate with the G-Node B PHY and the VNF. All right. And so the last part of the who, what, where, when, why is the why. So these are the benefits of the PHY emulator. We've broken it down to 3 main sections: the experimental methodology, industrial networking, and the development process. So experimentally, having a PHY emulator allows us to analyze various protocols, behavioral models, and various wireless environments, such as MIMO or SISO. And then industrial networking, it basically allows us to isolate a particular layer in the protocol stack, but we won't have the adverse effects of the PHY layer influencing that, so we can look at specifically the MAC layer, for example. And then lastly, the development process. By moving the PHY into completely emulated mode, we have controlled signaling, we're able to do scalable models, it's real time, we can repeat it, and it's a great test environment. Okay, so I think that's all I have. Let me know if you guys have any questions, and please come see us at our booth.